Said, yeah. So, okay. And they gave me like the first 4 words, and obviously not going in the direction that I should have been. And everybody thought it was super funny that I shut them down like immediately. So there's that. All right. We are playing around with that F word today, right? That's our goal. Okay, so on top, you guys already have this written. Factoring review, yeah? Or flowchart. Okay, now right off the bat, it's organized a little bit differently. We're going to make it fit because this isn't the whole story, just so you're aware. You've seen a bit of factoring stuff. There are some special cases that you may or may not remember, but if you have these basic ones, we're okay. Now, up at the very top of your sheet, it has 2 options right off the bat. It says immediately, before you even have to worry about arrows or anything, what's the first thing it says over here? To factor what? Okay, so yesterday I wrote that, I just wrote GCF. Like, even before any other thought that happens. And then next to it is an example, I think. Did I erase the example? Okay. So, yours didn't really copy very well, but you can't tell. Underneath that, there are like 3 circles like this that just, for whatever reason, they didn't copy through. Can you see them? Okay. First thing we checked, and we did these yesterday, very first thing that we're going to check after we've done GCF, always is what? Louder? Binomial, meaning what? So it could be. For this particular situation, you're absolutely right. Difference of squares is one of them that we care about. Binomial, 2 terms. That's it. Now, you have to be careful because this can be kind of misleading. But we have a few different options that we're going to deal with. So your arrows that were supposed to be here also didn't work out. If it's a binomial, there are 3 things that we're going to check for, and I'm trying to make it match the boxes here. So, first one, underneath you have that box on the very furthest left that hasn't been written yet. Just so you know, this is going to be a try over here, and then we'll figure out together what we're going to put on this very last one. But we're in binomial land currently. Now, how we organize it is not a huge issue. One option, and I'm going to switch it around. Very first thing we hope for, what did you say a second ago, Mickey? A difference of squares. So, I'm going to shorthand stuff. If it's a binomial, this would be the first thought that I have. Is it a difference of squares? Cool. And yours is going to look nicer because you have these arrows and stuff that work nicely. Or you can add your arrows, but you have nicer boxes. All right. If it's a difference of squares, and I'm just going to have the formula underneath of it, that's the first thing we check for, and you don't have it written down. I'm going to do the really, really general case without any numbers or anything, and then we'll do like an actual example of each of them, and then I have like a handful of factoring problems for you on the assignment that will essentially just be during class time. If you had 2 squares, and I'm just going to use this box underneath, here's like the formula type version, a squared minus b squared. Now, I don't know if you guys are cool enough to carry around a bunch of different colored pens and stuff with you. If you do, this would be a good option for it, but you don't have to. I'm never going to worry about it. Anytime that I do this work, if I'm showing work, and hopefully we won't, my work always looks as follows. What's the square root of that? A. What's the square root of that one? So I'm going to make that like note in my head, and I write those first. A minus b times a plus b. Every single time. That's what my work is going to look like. If you can identify the square root of it, you're golden. Now, weird little thing that happens. Do you know nice square roots? These are my warning signals, just so you know. Do you know any nice square numbers that you know the square root of? You can give me probably a ton of them. 1, 0, those are the easiest. 4, 9, 16, 25, 36, 49, so forth and so on, right? They keep going. But check this out. You're more mathematically savvy and you've seen stuff, right? What's the square root of 2? It's not a square number, but can you take the square root of it? And you literally just call it root 2? Anything could be factored this way. It just might be ugly and terrible to try to deal with, just so you're aware. Okay. We had one example yesterday, I think. Do you want another one? Okay, so on this one, I'll try to stay with this the whole time. Let's think here. I don't want it to be like crazy easy, but I also don't want it to be crazy hard. So let's think of the following. I want 20x squared minus 45, I think is going to work. Okay. Love it. Always, 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 the very first thing we check is what? That's not my random number calculator. Super weird, really smart calculator. Does everything I could ever possibly ask it to do. I don't know how to do the random numbers on this one. Don't know how. What's the first thing you always want to do? Number, we don't have that many people. Should I be a number? Okay, I'm number 13, just so you know. Number 3. I don't know who that is. All right, Huggins, always when you're factoring, no matter what, the very first thing you check. Awesome. Follow-up question then. We're going to check the GCF. Number 6, is there a GCF in here? I don't know who 6 is, so I'm just kind of... 5 goes into 20x squared, and 5 goes into 45. Boom, we have it. I'm going to factor the 5 out. Now remember, factoring is essentially division, so I'm like thinking if I divided, what would be left behind? Okay, I'm going to take a 5 out of each of these things. What would remain in the first one, number 13? Oh man, I bet it's 4x squared. Cool, good job. How about you, number, oh my gosh, Huggins, your number is showing up over and over and over, but we got number 9. That was cool coincidence. All right, GCF, taken care of. Now, at this point in time, the most common mistake, like it could have been an X that we factored out. That could happen. People regularly forget to bring this one along for the ride, but no, they're here to party. They're going to party with us. We don't leave them behind. Okay, so now as I'm looking at it, I just look, still a binomial, which is a good sign, inside of my parentheses anyway. Is it a difference? Cool, cool. It's subtracting. Do you know the square root of this one? Almost. Depending on what it's pointing at. 2 is the square root of 4. How about that x squared? 2x. So check it out. What are we going to do with that 5? Leave it. Bring it along. So be really careful. Leave it as in don't touch it. Like don't mess with it. Not leave it behind. Bring it with. Okay. So now let's just go ahead and dig in. The square root of 4 is 2 and the square root of x squared is x. And what's the square root of 9? 3. And you don't really have to fill it out like this because it's going to be awkward on your spacing. Before, I think I had it very specific on how I wrote it. Do I write plus first or minus first normally? I don't know that I have a consistent. Could it be minus 3 here? And then over here it's just 2x and then plus. Order doesn't matter. I don't care which one comes first. I don't know which one I do first normally. Difference of squares. Feel okay. All right. Can I go faster or slow down? Feels all right. I should never ask questions that people are going to answer with nodding and add like multiple answers. Cool. All right. So this one, I'm going to blast through. I don't know how much we'll see it right away. We will see it for sure. But maybe it's not a difference of squares. What's bigger than a square? A cube. So here's what I would like to do. To save a little bit of space on your stuff, I would just like to have sum slash diff of cubes. Now, we're going to see a symbol that I guarantee is something that has like shown up before, but maybe not in this order. For the sum or difference of cubes, turns out the formulas are so close to each other that they're going to be really easy to just write down in a quick statement. I don't know the word. Okay. Difference or sum of cubes. Here's what I'm looking at. I'm going to use A and B like consistently. What's the cube of A? It's a weird question. A cubed, right? Okay. So here's what I want us to do. We're going to do A cubed plus or minus, because I'm talking the sum or the difference, B cubed. If it's a binomial, that's a possibility. When you're dealing with this, the formula comes in 2 flavors, and I always remember it in a very specific way. What shows up first when you read this operation? Don't circle yours. How do you read that? Plus or minus. What was the first word? So when we look at these formula underneath, the plus is the one that comes first. So these always work I like them, but not everybody does. I'm going to take the cube root of each. Everybody cool with that's A and B? I'm going to keep it plus right here. That's my first factor, the first piece that comes out. Now, we're not deriving it, seeing where it comes from, things like that. But I'm just going to give this to you. We're going to use one little weird switch. I'm going to start with a squared. That ensures that I'm going to get my a cubed out of the deal. And then we're going to switch signs, minus, and we're going to multiply these two together, both the roots that we took. So that would be ab in this case. And then we'll add back the b squared to ensure that we get our b cubed. A plus b cubed, you start with a plus b as your first factor, and then it's a squared minus, and you make that little change. Okay, or if we didn't do plus, it would be minus, right? So we'll do a minus b, but the trend stays similar. If my first one winds up being a minus b, I still need an a squared, but what is that second sign going to do this time? It went from plus to minus. Now it's going to go from minus to plus. And nothing else changes other than those two signs. AB plus B squared. Have you guys done these, you think? Do you want an example of this as well? Yo. On the last one here? Yep, because we need to make sure that it winds up as minus b cubed in the end. Am I wrong there? No, I'm good. We're cool. Good question. Okay, let's do one real quick. That's not crazy. One example, and let's do one that's not even a little bit wild. 8x cubed. You want plus or minus? Okay, minus 27. First thing we check always, what do you think, Barsega? Is there anything that goes into 8x cubed and 27? I don't think so, because 8 is just 2 times 2 times 2, and those are all prime, and 2 doesn't go into 27. All right, do you know the cube root of 8? 2. Do you know the cube root of x cubed? Okay, so I know that that is just 2x, going to be my first, that's a cubed root. And then is it going to be minus or plus when I plug in? Minus, what's the cube root of 27? 3. There's our first factor. Now, as long as we've identified a and b, the rest of it at this point is honestly just plug and chug. There's nothing else to it. You take this a term, the first one, and you do what to it? So here's big moment of truth. What's 2x squared? 4 times x squared, right? 2x times 2x gives me a 4x squared. What's my new sign? Plus, and then this is weird, we have to ignore it. Notice that I didn't say, like, I didn't worry about the sign of b in here because it deals with itself. What's a times b? 2x times 3. Notice, we just used b, not the sign with it, just the value. Last one is going to be plus the square of 3. 9. Is it possible you don't memorize this formula? Probably. I'll tell you, you will memorize it when we start factoring stuff, so we use it more and more often. Right now, this one is nice to have because I think you've seen it. This one you should have. And it'll take a little bit of practice too to get it like stuck back in your head, but we'll get it. Okay. Did we fill in? Good. I'm going to keep looking at yours because you're the closest person. I'm going to make sure that it lines up because mine looks very different with different words and stuff. Okay. Feel all right there. What if it's not a binomial? Bet. Cool. What's a trinomial? That was mumbly. I think you're right, though. 3 terms. Okay. Now, you have an extra box directly underneath it just to make sure we know what it looks like. If we're looking at a trinomial and you get this new box right here, there's no space if you even put an arrow. We're going to look at the general form. Now, we looked at the general form of a polynomial yesterday, and it's really ugly the first time you see it, but it just looks that way. It's not. Trinomials, especially when we're looking at easy factoring, have the form ax squared plus bx plus c. Now, realistically, there's only one way that you need to be able to do this, and it's called grouping. Factoring by grouping is something that you don't have to remember a single other piece throughout the whole process. I don't know why my phone is in my pocket. That's my bad. Don't have to know anything else, but there's shortcuts and efficiency is always beneficial. So anytime you're looking at this, there's another statement right below, and then we get two little boxes, I believe. The statement there underneath this is a simple question. Does the leading coefficient, and I'm not going to write that, what is the leading coefficient of this trinomial? A, the number connected to the largest power of the variable. So the only question that you have to ask first, does A equal 1? Okay, every time. If it equals 1, you are like in for a super handy shortcut, hopefully. Two options. In your page, we now have yep or no. I want to say nope, but I don't want to write it that big. Okay. For the shortcut, there's like a bunch of different ways that we can word this. I'm going to try to be as few words as possible where it still makes sense. If A is 1, I draw them. I don't want to just work an example yet. We're just going to write the following. Find numbers that multiply to whatever A times C is and sum to B. And I wish that there were a nice, like, pretty formula to look at this, but there's not. You need to find two numbers that multiply to be whatever A times C is, but they have to add up to B simultaneously. Both of those things need to be true. So let's do an example of one of these. And I'm not going to go through with generalizing, because I think if we do one, we'll see just how nice this is. Okay, so I'm going to do one example here of something that factors nicely with a leading coefficient of 1. Let's say we have the following. I don't need that. X squared plus 4x, and let's say plus 3. Okay. We're doing an example of this very specific case that's unbelievably nice, and you may have to jot a little bit down outside the bubbles just so you know, because the way it works out. What's the leading coefficient there? Love it. The fact that that's a 1 means there's not going to be any meaningful GCF that has a number. There's no other GCF anyway. Cool. If it's a 1, I love it. I'm going to go straight down, right? What's the leading coefficient A here? 1, and what's the constant C at the end? Now, my notation, you may not have seen it. You've probably seen me do it. I'm not going to write the 1 there, but I could. I draw mine like this. 1 times 3 produces what number? Okay. Now, I wish I'd picked a harder example so I could show this. We will see another one later. I'm sure it's on the homework. I now need to find two factors that multiply to be 3, but they have to add up to what? 4. Now, this is why I hated it. You guys may like run through a list in your head, right? This one's unique because there's only 3's prime, so this is not interesting. Is it possible you had to check like 5 different things though? And maybe there's a lot of different things that multiply to get this, and now you have to go through that whole list. My advice to you is if you can't find it right away, go through them systematically. And what I mean by that is, what's the first way you guys think to get to 3? 1 times 3. Now, this is, again, a lame one because what does 1 times 3 equal? And what's it add up to? We found it already. Don't write this one down. Pretend we had a different number, and I had 2 times 5 and 4 times whatever, 5 I guess in that case. I'm just making up numbers right now just so you know. I'm saying there was a bigger list pretending. If you're running through a list and you're making a big list, blah, 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 like this, and you're just thinking it, is it possible that like on accident you skip one? If you write them down and make sure that you start going with the smallest and working your way up to hit everything that goes into it, you're going to ensure that you don't miss any of them. Doesn't happen here. Now, we didn't though, so that's cool. I refer to these as my magic numbers. They're not really magic, but it feels like magic when you see it. If the leading coefficient's 1 and you can find these numbers, we did, we're done. We have one step left and we can write our factors immediately. We need it to be x squared in the end, so I know it's going to be x every time if a equals 1. Plus, what was one of those two numbers we found? 1. And it's a positive 1, that's why it's plus. And what was the other number we found? And it's a positive 3, we're factored. Every single time, if you can find those magic numbers, this works. Now, just so you guys can see what I've elected, I just use slightly different language, and I write it down differently. On the one that has all the stuff filled in already, they go through this whole thing and say, hey, let's look at this and have blank spaces for numbers and use an X, and I despise it. We're doing the same thing. If you want this copy, I can certainly give it to you. But I think the language that we all agree on, or that rather I make you agree on, will probably help more. Okay. Y'all remember that shortcut? Okay. I'm going to look back at yours. Okay. If no, we're going to work, thank you. We're going to work this way. And I'm going to say grouping. Now, for grouping, it's the same process as with my shortcut, but we don't get the shortcut to use. And we're going to have to be a little clever with it. So, same thing, multiply. Yo.
Like
I went over to the right because we're going to have a box that we'll just make a comment in at the end.
what? So like put grouping as the top one?
Nope, you do not. I would put grouping right here, and we're going to have a blank box. That's just going to say like, but wait, there's more or something, because we're not going to go over every single possibility right now. We haven't learned every single possibility yet. I should have just deleted that box. That's my bad. All right, mult. Anybody have a shorter statement here, or is this cool? Mult to AC, sum to B. It's like the same question, but we have to do something a little bit different. Mult to AC. Do you guys know the shorthand for sum? Like a adding up. Obviously, plus is the symbol. Have you guys ever seen this Greek letter? That's the shorthand for sum. You hate it. It is, yeah, it's a capital sigma. Yeah, absolutely. Okay, lowercase sigma, just for fun, is this one. But, okay, we'll say sum to B. All right, now here's the big deal with this. The magic numbers are going to be harder to find. Like, they're just going to be harder to find. Our whole goal, and we're going to work an example, so we're going to have an arrow going down. You can elect to write this part if you want, but it's just a little comment like an annotation. This next part, we started with a trinomial, and trinomials maybe aren't always easy, like this. We are going to rewrite, instead of having 3 terms, we're going to rewrite with 4. And we'll have to look at how this works out, because there's not a nice way to do this generally. So we're going to do an example and see this actually happening, and we're going to fit it in that box so it can't be too crazy. So what's your favorite integer coefficient binomial of the first degree, meaning power of 1?
What do you mean by rewrite with 4?
We're going to do it right now. We'll see it happen right now, because I don't have another way to word it, but you guys can probably help me. Give me a binomial that's not leading coefficient of 1. JV, we made eye contact and you looked away. Any binomial. Something x minus or plus something else.
Something x minus 2x plus something.
Sure.
Plus 8.
2x plus 8. And we're going to multiply that 2x plus 8 by, what do you want to multiply it by, Kalisha?
4, 5.
So I heard negative 5x plus 1?
Yeah.
Okay. All right. So you don't write that down yet. We're going to get those out. Fancy calculators, you've never seen it. If anybody takes calc next year, we got calculators for everybody. Look at me expanding on this guy. It's just doing it all for me. Cool. All right. I want to factor the following. Let's factor negative 10x squared minus 38x plus 8. I'm going to try my very best to fit it all in that one line, but it might kick underneath. Oh no, first step, always, every time. What do you got, Angel? GCF. Now, quick question, I think we all agree. What's nicer? Negatives or positives? Oh my gosh, okay. So right off the bat, I can factor a -1 out. I know I can do it because it's going to make me a positive x squared. That's easier to deal with. Is there anything else I can take out? 2 goes into all those, so let's do that. I'm going to factor out a -2 then, because I want that positive x squared. So here we go, -2, and it's along for the ride, right? We're not going to leave them behind. And what remains within? Okay. Right now, Huggins, just want to specify in case you're looking at it going, oh, that's the 4 terms. We're not there yet. We haven't done 4 terms yet. That -2 just happened to show up completely on accident, just so you know. Now, we got to look at this thing. And we're back to just a regular, nicer trinomial now. It's simpler. Is the leading coefficient 1 yet? Ah, bummer. So we're still on this no trail. What 2 numbers should I multiply? 5 and -4. And I'd always do it like this. What do those multiply to be? Okay. This is a better example. I'm going to, gosh, no, it's not. It's still awful. Give me a way to get to 20. The first way that comes to your mind, maybe without this problem in your thoughts. 4 times 4, right? 5 times 4, 4 times 5. Don't matter. The order doesn't matter. Now, that's where my mind goes first. JV, you smirked a little bit. Did you notice why I didn't like this by chance? It's just going to work out the same way. If we go systematically, you shouldn't start at 5 or 4. Does 1 go into 20? Okay, so I'm going to start at 1 every time. Now, whether you have to write it or not doesn't matter. And I hate that this worked out the same way. But 1 times what to get -20? Okay, so here's, notice, I didn't write it, but you're right. Here's where I need to be careful. Those numbers right now multiply to be positive 20, so they're broken. It has to be negative, but it has to add up to what? It has to be positive 19. One of those numbers, 1 or 20, has to be negative. Which one is it? -1. Now, again, total accident that it was the very first number that we've found. We're going to have another arrow down, I assume, to this very last box, just so you know. Okay, once we find these magic numbers, which is often the hardest part, we get to do more stuff. Don't write this, but if I wanted, hypothetically, a different way to get to 20, what's the next combination you would make to -20, sorry? 2 and 10. Does 3 go into it? Nope, does 4? 4 times 5, does 6? 7, 8, 9, nope. 10 does, but then we're back to just our list. Okay, you should list them out systematically like this. We don't need them this time because we found our numbers. Okay, so are you guys probably about done with that box, yeah? Like, we can go now? Now, here's this big part, Huggins, because this is just one long example. This is the rewrite with 4 part. I don't like 3 terms. It's hard to deal with 3 oftentimes. What do we do with the -2 at the very front, first of all? That's right. You put them to bed, you tuck them in, you give them a nice kiss, and make sure that they stay there. So, here we are. When I throw just like random crazy stuff out there, does it at least make you go, what? So that you're paying attention more? Okay. That's the goal. If it ever gets too weird, would you tell me? You guys ever watch the Eric Andre show?
Yeah.
Okay. Let me know if I become Eric Andre. All right. Do you guys like it when you have lots of parentheses in a problem? Yeah, so like 2 sets of parentheses or parentheses within parentheses and stuff. Now, just so you know, there's 2 ways to deal with it. I know which one I prefer, but I'm going to let you deal with this in a second. I'm going to use parentheses inside of parentheses. We have 2 options. I either do it like this. Here's nested parentheses, so it's very clear to tell which ones are inside. Like, that's the one that I like most of the time. Sometimes there might be another set of parentheses and things just get crazy and out of control, right? Like, we don't want to just keep making them bigger and bigger and bigger. If only there were another grouping symbol that wasn't just a parenthesis. You can bracket. And these are interchangeable. They don't mean anything in this context, When we're talking about solutions, they will. They have different things. What would you prefer, parentheses and parentheses or brackets and parentheses? Good. I like brackets too. So check this out. Here's the big deal. We wanted to rewrite with how many terms? We're going to take our 3-nomial and make it a 4-nomial. And we're going to use those numbers. So these magic numbers are related to this value b. That's why we found them. That's how we found them. I'm going to rewrite this term using 4 in these numbers. So bunch of color changes coming. I'm going to leave first and foremost an awkward space because I am going to add some parentheses inside of here shortly. So there's my first bracket, and then I'll add parentheses in a minute. I started with 5x squared. It's going to hang out. What were the two numbers we found? Our magic numbers, quote unquote, when we went through the whole AC thing. -1 and 20. Is it possible that we had done 20 and -1? Doesn't matter. Now, I'll tell you, I'm already thinking ahead because I know I'm going to put parentheses around it. Would you rather try to take something out of 5 and -1 or something out of 5 and 20? 5 and 20 have a bigger thing that we can take out. I'm going to switch the order, but you don't have to. Okay, so I'm going to replace my 19x with those things. So instead of 19x, it's plus 20x. Okay, awkward spaces happen again. Minusing is pretty cool, but you know what's cooler than just thinking about minus? Adding a -1x. There's a reason for this, I promise. Plus 8. Sorry, it's -4, right? Because we factored out the other one. Now, awkward space. Is this line here really any different than this one? They look wildly different. Well, we've rewritten this exact same thing, but with 4 terms, because when you combine them, we still have the same thing. Okay, we're going to add our parentheses. We now have how many terms inside of that larger bracket? 4. Can you cut that into 2 smaller groups pretty easily? 2 groups of 2, I would guess. Let's try that. Can anybody tell me why it was so, like, why I stressed this plus a negative part? And did you stress that last year if you recall doing this? Okay, don't write it down this next line. I just want to see what would happen if we hadn't. If you don't make it plus a negative, you're leaving yourself open to huge mistakes. Because if we try to group this without doing that, like that's the same thing. When I put these groups on, is it the same now? This is wrong, just so you know. Why? All of a sudden we added multiplication somewhere where it never belonged. The other alternative is somebody goes, oh, well, I'm not going to make that mistake, I'll do this. They're still wrong because it's -x minus 4. If you distribute, it changes everything. That plus part in the middle right here, super duper important. Okay, uh-oh. Cool. So you're gone. All right, almost done. Can somebody tell me where to go next? So real quick, silent because you're not sure, or silent because you just don't want to talk? Not sure? Okay, and that's okay because I want to know if I'm going like super slow or not. Okay, this -2, can I just ditch it? It's a nerd, it doesn't belong here. No, it comes along always. I'm going to keep my brackets. I'm only going to use one color. What goes into that first group? Or rather, what can I factor out of that first group? 5 and x. Okay, let's do it. I will factor out at 5x. Upon doing so, what does it leave behind? X plus 4. Okay, we're at a point in time where we're going to know if we're right or not. Whatever I factor out of that other one, I better be able to find something that leaves behind exactly x plus 4. What could you factor out now? At this point, am I safe to do this? -1, you can write it if we should write it, x plus 4. I can ditch my plus and negative now because I'm not worried I'm going to like forget about it. Can you feel that we're there? Okay, right now I'm going to let the negative 2 ride along. Can you guys identify one of the two factors? 5x, and I will use some squiggly underlines, minus 1. Love it. Can you give me another factor? X plus 4. Now, that part always felt like magic to me. You probably discussed in Algebra 1. Do you know why we're allowed to do that? Okay, so I'm going to show you not to write it down. We're done with this problem, just so you know. Because if you've never seen it, it probably doesn't feel like it has a real, it just feels like a shortcut trick. If I were to multiply 5x minus 1 times x plus 4, and this is just the opposite direction, we FOIL, right? We distribute. If I were to draw my lines, my curves like you should, and I will encourage you to, I'm going to draw this one, FF, right, first, and outside. Are those the first multiplications you guys do? We literally just took 5x times what? X plus 4, right? That's literally what we just did. Minus a 1 times what? It's just undoing that operation. If you've never seen it, it feels like, oh my gosh, wow, that's so obvious. It's not unless you look at it and think about it. Okay, how many spaces do we have left? 1. I'm going to say this very last box on the very top. So we did a bunch of trinomial work, a bunch of binomial work. This is honorable mention. Or later, if you'd just rather see that. Okay, I'm not going to write anything here, but we're going to talk. I'm going to throw out some language that I'm hoping you've seen. A perfectly square trinomial. Perfect squares. Okay, follow-up question. Who taught your algebra 1 class? Jarvis taught algebra 1, or Russell taught algebra 1. Okay. Algebra 2 was Osmond. Did you guys, you did a big graphing or factoring chapter last year, I'm sure of it. I'm going to throw this out here, just a couple questions. You may not have any idea what I'm talking about. If I wanted to do x plus 4 squared, anybody ever look at it like this? X by x and 4 and 4. And now we have this area model. Have you guys ever done that? Do you like that? Okay, it's fine. It just gives a little bit of motivation for it. What if we have this? X squared plus 6x plus 9. If we run through this, and this is just a good example, you don't have to write it down if you don't want to, we'll talk about it. There's a shortcut living here. What's the first thing you always check? Is there one? No. Is it a binomial? No. Is it a trinomial? What's the leading coefficient? Fantastic. I love it. Why do I love it? How's the shortcut work? What should I draw in here? Or what should I multiply? 1 and 9 make... Okay, I need factors of 9 that add up to what? Okay, now check this out. This one finally works. Is it that? Bummer. 2 doesn't go into it. Is it that? Okay. You probably don't have to write them. If you can't find it immediately, start listing them all out. I want to stress it. The fact that this is a 1 says I don't have to group anything. I can just use my shortcut. Can you tell me the first factor? X plus 3, because that's a plus 3. And what's the second factor? And we shouldn't really write it like that. We could just do this. Now, the way that you, does this look familiar to you? The way, I don't know the exact language that Miss Osmond or Mr. Russell or Miss Jarvis used. The way that I look at it is, the square root of this is what? The square root of this is, multiply these and double it. 3 times x and double it. Do you get 6x? We do, right? So check it out. We're going to use both of these. I have an x and a 3. I know the same factor is going to repeat. What's the sign here? There's a shortcut for it. They can get bigger even if it doesn't have that. What's your favorite non-leading coefficient 1 binomial? Who haven't I called on today? Sean, give me a... Oh, I startled you. Sorry. Give me a binomial that's not 1x. Yep. Ooh, love it. What's your favorite number? 7 is mine. Cool. So check this out. We're going to have 4x squared plus 28x plus 49. And I lied. I want it to be minus 28x. I should probably write the x there. What is going on? So if today feels like really disjointed and like clunky, the reasoning behind that is because we're taking like 2 weeks from Algebra 2 and shoving it into a 55-minute lesson. Plus I have technological issues at the beginning. My car wouldn't start, had a flat tire, my dog ran away, all sorts of issues. Okay. GCF? Is it? Yes. It was 49. That was my bet. Oh. All right. GCF?
Oh, wait, no.
Got you with the 49 because I miswrote it. There isn't one, right? Okay. Leading coefficient 1? Oh, no. Okay, so we have to group. What's 4 times 49? That's right, 196. What factors of 196 add up to 28? Negative 28. That's a bigger problem, right? It's literally the same thing. Turns out factoring numbers is hard, and that is awesome because it means that your internet security is good. Like all of your credit card information that's saved everywhere only relies on the fact that it's hard to see if a number is prime. Like it's a really hard question. Okay, but check it out. We're gonna write this one down. You should try it. Before we go through this whole mess, before we do it, I'm gonna check something else. Do you know the square root of the first one? Do you know the square root of this one? If you multiply these and double it, do you get this? What's the sign here? 2x, 7, it's a minus, and it's squared. There's a shortcut for these if you see it. If you don't see it, is it going to destroy you? No. 14 and 14 are the magic numbers that you'll eventually stumble upon as you go through your list. You'll group it, you'll factor it, you'll get the exact same answer, but we'll save time. All right. One more thought. Last one, and again, don't mind if you work it or not, but we're going to see something wonky here. This one, at the end, we'll probably write something else down. So we did perfect squares. That's what we just did just now. The other one that we'll look at is, let's think, x squared plus 5x plus 5. Does that look, before we do anything, easier or harder than all the others we've done? Is it on the easy side or the hard side of stuff? Looks easy, right? Okay. GCF. It's a trinomial, and what do I see that makes me go, yes, good, thankfully. Okay. 1 times 5 is? And factors of 5 that add to 5 are? Nope, that's 6. Nope, those add to 6. That's 0. Pack it up, call it quits, right? We're just done, it's broken. It's like, that sucks. Sorry, universe. No, we can't find these numbers. Now, there is something, however, that we all remember, like, just so ingrained within us, that we would have to work backward if we're factoring, but we could solve the equation and get the factors out of it because of those 4 equivalent terms. X, when I solve this, and I'm going to set this equal to 0 in this problem because this is what we'd have to do. Well, I know the roots, the zeros, the solutions, the intercepts, whatever you want to word them, can be found by simply plugging in negative b plus or minus the square root of b squared minus 4ac, and all that over 2a. You know it, you love it. This is the what? It is the quadratic formula. I don't want to do the quadratic formula right now. We will have to eventually. Do you guys remember that formula? Uh-oh, is that stress about this or other things?
Like moving my leg and I keep hitting her leg.
I can feel it. It's weird. All right. Could you guys do this if I had to? We will do it, but not right now. I don't think we need to right now. Okay. Let's It's a lot of stuff, really fast. Any of it look new to you guys? Good. Sorry if that was like the most boring 50 minutes of your day so far. Well, I got homework, so that's pretty cool. Let's do some problems. I'm going to give you a heads up right off the bat. There is one problem on the homework that I am certain I didn't talk about. And I didn't talk about it very intentionally because it's going to ask you to find something. You'll be like, what? What is that even? Holly didn't talk about it. That's BS. And then you're going to think, oh, it would be BS if I had them. It would. Dang, I had a whole story in my mind to make it work and it just fell apart. If only you had an additional 10-pound resource and you knew that we were working in section 1.5 and you can turn back a page and see that, oh my gosh, all these words that we've used and I've used were here. Okay, I'm giving you homework. Over the weekend, don't destroy your life doing my homework. You wouldn't because you'd be building mathematical knowledge and practice, but don't let it ruin your whole weekend. Your homework over the weekend, 1.5. Gosh dang it. Did he put it on the classroom yet? Sure hope so. He didn't. Not there. Ah, he did here though. All right, over the weekend, homework 1.5. You will find this on page 56. All right, random ones, okay? It's always going to be just super random, so I don't have to give you like 40 problems. First ones are nice. 1 through 7. Okay. Then 11 through 16. You do not have to draw pictures. I don't care if you draw the picture. I think it says copy it from your book. Don't just draw in your book with a pencil and then erase it. So do it lightly. Okay. 20. 24. 32. 34. 37. 61. 71. I'm going to put an asterisk on 84 because if you bring me 84, which, let me verify that this is true before I tell you this. If you bring me 84 and you can explain it to me, and if you're the only person in the class, I will provide you with a late homework pass so that you will not get docked points. More than one person can get it, but it means you have to explain it to me. Cool. 84, you should try it. If you can't do it, don't beat yourself up about it. Try it. Cool. We have exactly enough time to watch my favorite YouTube video on my very most favorite YouTube channel. I shouldn't open that door. I should never do this again. Right, JV? Too much. Yeah, I agree. My favorite YouTube channel is Daily Dose of Internet. If you guys have never seen it, love it. Last year, I'm pretty sure we watched a Daily Dose literally every single class, every single day. Not gonna let that happen. Cool. Other things. So you guys have a bake sale tomorrow at Safeway. I will swing by at some point. Rocketeers. If you happen to want to come practice or learn a little bit about Rocket League, tomorrow, 2 to 4, be there or be square. I will open the doors by the pool, and we're going to practice in Marquette's classroom. If you have a control or multiple controls, please bring them. PS4, PS5, or Xbox. Bring the cord that you use to charge it. We still have 3 minutes. You guys can stand up and stuff, but don't wait at the door like cattle. Bring your controls if you have them. Cool. Other than that, you're going to have to find time tomorrow night to do your homework or get up really early on Sunday because the Dallas Cowboys play at 11. Whoa, not 11. I don't live in South Dakota. 12:30, I believe, on Sunday. They play the Cleveland Browns. We're going to win. Eagles, and I picked the Packers tonight. Yep, they're playing in Brazil. No Sao Paulo. Okay, for those of you that I can already tell, if you don't leave your book or take a picture of the last couple pages, because again, I promise there's something in your homework that I did not directly teach you. can. Yes. I would recommend. Do you have data on your phone? Do you have data on your phone? Do you have Desmos app on your phone? That's what I recommend you get. Have you ever used Desmos? It's. Have you guys used the Desmos app yet? Does it work just as well as your calculator?
Is it that graph?
It's the graphic thing. Yep. 45 seconds. What can you